Welcome, dear viewers, to the video on dissolution testing. In this video, we are going to learn regarding the sink condition differences. So, you might have come across a situation where the dissolution release or dissolution test shows the difference in the release rates between higher strengths and the lower strengths. For example, if you are working onto a formulation with the strength of 500 mg, 250 mg and 125 mg, and in this you can find that the dissolution rate of lowest strength, that is 125 mg, is faster compared to 250 mg and 500 mg. Or in other way, you can consider the 500 mg or higher strength is with the slower drug release. So why this happens? Why there is a strength specific dissolution rate, and what is the reason behind this observation? So the reason is sink condition differences, and this is the topic for this present video. Be with me till the end of this video to understand these conditions. First of all, we should know about the sink condition. So sink condition is maintained when the dissolution volume is such that which can dissolve at least 3 times of the dose of the strength being studied. For example, if the strength is 500 mg for the formulation, then the dissolution volume should be such that it can dissolve at least 1500 mg of the API. The dissolution media may or may not contain surfactant. The dissolution media volume may be 500 ml, 750 ml, 900 ml or 1000 ml depending on to the formulation. So sink condition is affected by BCS class and the solubility. The solubility may be BCS solubility, or it may be the saturation or equilibrium solubility. So comparison of lower and higher strength, we'll see a look at how dissolution behavior varies with different drug strengths under sink conditions. So for dissolution testing, sink condition is required, and if sink condition is maintained, then we can say that the dissolution condition are proper and dissolution test is being run with the proper sink condition. Sink condition in dissolution testing refers to a maintaining a concentration of the drug in the medium at such concentration or at a low concentration which is enough to ensure the constant dissolution. The dissolution test is done with sink conditions, and the dissolution rate is constant and not limited by the saturation of the drug in the solution. To study the effect of varying strengths of the drug under sink conditions, we should understand how the sink condition varies with different strengths. As I have taken an example of formulation with 3 different strengths, 500 mg, 250 mg and 125 mg. So your dissolution medium should be such that it can accommodate at least 1500 mg of the API, or it should dissolve at least 1500 mg of the API. So if you maintain such sink condition, you observe that the dissolution is faster for middle strength of 250 mg and it is still faster for the lower strength, that is 125 mg. So this is because the sink condition differences. What is the importance of sink condition in dissolution testing and why the sink condition are required? So sink condition is required to ensure consistent dissolution kinetics. It is required to prevent saturation, and this saturation can affect the dissolution rates. Sink condition facilitates prediction of bioavailability and the release profiles. If we work without sink condition, there are more chances that the saturation will happen and the true picture of dissolution profile will not be reflected by the dissolution testing. Now we'll see regarding the lower strength and the higher strength. What happens for the lower strength? What happens for the higher strength? So lower strength has lower dose, and that's why there will be less drug in the dissolution medium. So there will be always faster dissolution. The drug concentration will remain below its solubility limits, so the rate of dissolution is predictable and it is steady. Lower strengths maintain the sink condition. The concentration stays low, keeping dissolution kinetics constant. Higher strength formulations under sink conditions. Higher strength may also be under the sink condition only, but there will be the more amount of drug in the medium. There may be more risk of saturation. The concentration of the drug may approach or exceed solubility limits, and that's why potentially disrupting sink conditions. So there are some challenges for the higher strengths. Challenges are that higher strength requires more resolution medium to maintain low concentration relative to the solubility. But taking more volume also is a challenge because you cannot take more amount than the recommended ranges. Effects of saturation on higher strength. So there will be such a saturation point as the drug dissolves, the concentration may approach drug solubility limit, and that's why there may be a deviation of sink condition. If the concentration reaches the solubility limit, the rate of dissolution will slow down, and then you can observe that diffusion controlled dissolution is happening. And in saturated solutions, dissolution is limited by diffusion, leading to the slower drug release rates. Now we'll see the volume of medium. Because to maintain the sink condition, volume of medium is required. So for lower strength, generally lower strength need less volume to maintain the sink conditions. Higher strength require more dissolution medium to prevent reaching the saturation and to ensure that the concentration remains below the solubility limit. So there is always a critical balance of volume. The volume of the medium should be such enough to prevent saturation for the higher strengths. Comparison of the dissolution rates between higher and lower strength. Lower strength will have more predictable and steady dissolution with less likelihood of saturation, ensuring consistent release profiles. But it will not happen or it may not happen with the higher strength formulations. Higher strength will show initial higher concentration and will have potential for faster saturation. Then it will lead to slower dissolution once the saturation occurs, leading to non-linear or slower release. And this is the main reason behind slower rates for higher strength and faster dissolution rates for lower strengths. Now, key differences in the sink conditions. Lower strength, there is less risk of saturation, ensuring steady and predictable dissolution generally requires less dissolution medium. Higher strengths have a risk of exceeding the solubility limits, requires careful consideration of medium volume to maintain the sink conditions, and there is a potential for slower dissolution rate due to saturation effects. So we should ensure adequate dissolution medium volume for higher strength of formulations to maintain the sink conditions. We should monitor the saturation point closely for higher strength to avoid the nonlinear dissolution profiles. Both the strengths require careful formulation considerations to accurately perform dissolution testing, and to ensure the reliable bioavailability predictions. Then another point I want to include here is strength specific dissolution specifications. You can give some specifications for lower strength. Difference will be there for the medium strength or middle strength, and the higher strength will have different dissolution specification than the middle and lower strength. For example, if lower strength gives dissolution of more than 85% in 15 minutes, so you can set Q point of 15 minutes in lower strength, Q point of 30 minutes in middle strength, and Q point of 45 minutes at higher strength. Also, to maintain the same saturation, you should calculate the sink factor. I have made a separate video on sink factor. You can go to that video and get the idea about sink factor. So calculate the sink factor for the strength, different strength, and then calculate the volume of media or calculate the amount of level of surfactant needed for that particular strength. For example, if you are using SLS as 0.5% in water for 500 mg strength, you can reduce that concentration for the lower strengths proportionately, and then you can say that the same sink conditions can be maintained and you will get the similar dissolutions, or you can say that there is no difference between the sink conditions. So you can adjust the volume also, and you can adjust the dissolution specifications also. Nowadays I come across the dissolution method with the different SLS concentration or different surfactant concentration for the different strength of the same formulation. For example, for 100 mg strength, the SLS concentration is 0.2% in water, and for lower strength, or you can say half of the strength, that is 50 mg, the SLS concentration is half. I hope this video will help you to understand these terminologies and why there is faster dissolution for lower strength and slower dissolution for the higher strength. Thank you for watching the video, and please share these videos to your friends and colleagues. Thank you.